Welcome back. It's 5 September. We're on the other side of the Labor Day holiday weekend now. And you'll notice that after the two assignments, the article review and the solution, what is due today by 3 p.m. was your ability to set up and configure the PG Book virtual machine on your own personal technology. Now, if you ran into a problem or an issue, you may have some opportunities to get that in before Thursday. We will be posting the Module 1 assessment after today. So when our class ends today, I will post inside here at the very top, it'll show 1.5 Module 1 assessment, and that is an assignment you need to complete no later than 3 p.m. on Thursday. So your first attempt of the Module 1 assessment must be complete no later than 3 p.m. Thursday, no exceptions. We will review each of the items in the assessment and then post an opportunity for you to reconcile any gaps in understanding or mistakes that were made on that assessment. And since we are bearing down and getting ready for our first attempt of a module assessment, I did review in brief the Module 1 study guide, and I found that there were some edits, some quick edits, some updates that needed to be made so that it was tracking with this year, the dates this year. So I ended up, for readability, I ended up revising the Module 1 study guide, version 1D. I also included that as an attachment in the email. If you have previous versions of that study guide, you should toss that. What we'd like to do today is finish content review for the study guide and the addendum, and then open up the session to assist anyone with issues for submissions with the solution or the article review, so we can troubleshoot and sort those out. Does anyone have any questions about what our plans are for the week at this point?
No, but when I was trying to do the solution and I downloaded the PG book, it didn't work.
It didn't complete the download?
Yes, it completed it and it's there, but when I can't open it or anything. It's hold on, let me see.
And okay, tell you what, let me just mention this and then we'll take a short side trip. And can you show your screen? Would you be willing to show your screen?
Okay.
Okay, so in the third student learning objective, how best to organize essential criteria for a scientific computing application. It reads, you are expected to know verbatim the content covered in part 1 and part 2 of Coding Essentials. And it says, see part 1 and part 2, dated 29 August. The older C1 study guide 1C, 1 Charlie, the dates don't track with this year. And the links now pull to the YouTube videos for this year. So this is from the 29th of August. There's a 2-part session that we recorded, and it covers coding essentials, right? So that's one thing that we wanted to call out, so that if you had been working through the study guide and as you prepare for the assessment, if you click the other links on the old version, that'll pull from the year before and doesn't track quite the same way. I'm gonna stop sharing, but please remind me, Chimera, right?
Yes.
So please remind me when we're done sharing the screen on your side to share the screen again on my side so we can continue the review. We needed to continue. Let's see, we were down, we were here basically. Let's see, we had Anwar join us just a moment ago. Good afternoon, Anwar. How are you?
I'm good.
I'm glad to hear it. So let's let Chimera show her screen.
Okay, so basically after I downloaded it, the first download, that's what it is. It's not, yeah. Just delete it and re-download it.
Yeah, that's a partial download.
Okay,
So are you on the St. Thomas or St. Croix campus?
St. Croix.
Have I got a deal for you? Are you going to be on campus tomorrow?
No, but I can come over there.
If you stop by, I can hand you a thumb drive and you can put it on your system with the thumb drive.
Okay,
All right. And then you
all
can
right.
finish and then get the solution in by the start of class on Thursday. Okay?
Okay, thank you.
Yes. Anyone else was having some quick issues with assignments or solutions? So, hearing none, what I'd like to do is kind of emphasize again this idea that numerical data, when you have scientific computing scenarios that involve mostly numbers, you're going to want to use a spreadsheet. And this view of a simple spreadsheet is actually much more legible. We did review in brief in our last class that each of the cells of a spreadsheet can be used for inputs or for process or for outputs. And it's, you kind of have to think about your thinking to understand that. So that's called metacognition. And metacognition is actually a useful thing in scientific computing. It's when you take the time and energy to think about how you think. So it's sort of like an old karate movie I saw where it's like the art of fighting without fighting, right? Except that you're flipping thinking by thinking about thinking. And if you look here at this title, that's informing the user what this spreadsheet is all about. So this is actually considered to be output. And that's a simple text message that's been entered into a set of cells that were combined or fused, right? And so it's output. And in that sense, the application, this spreadsheet as an application has outputs that kind of inform or prompt a user about what's happening on screen. So there's a coefficient. That's a fancy $64,000 word, and we're going to go into this in quite a bit more detail in the next module. But coefficient, another word for coefficient is constant, right? So when you're looking at the formula for kinetic energy, or the energy that an object possesses because of its motion, there's a constant in that formula, 1/2 mv squared, m for mass, v for velocity, right? And I just wanted to talk through a little bit of this because you're going to see this again. There's a rate of increase. So there's another constant that you can specify. We could say enter a rate of increase if you wanted to be more explicit. And you could say enter the constant mass right here. So we could basically combine those cells and then be more descriptive with our output. Cells can also be used for input. So each of these numbers that are entered, right? As you go down the screen, there's calculations in the way of a formula. So if you click here on one of these cells, there's actually process being performed. And then the process that's being performed is viewed here. Let's see if we can get a little closer in on this. Trying to get zoomed in some more. So each of these cells in this column contain in an IPO table, you have input, process, and output. You have a formula. This is what the formula calculates. So there's mathematical process that's performed here. We'll explain more about this in the next module, but basically the process that happens up here is happening behind the scenes or behind this cell. So there's process and then there's output. The result of this computation here is displayed here. Because I've selected this cell in column E, row 5, you'll notice right here, there's a cell reference. This is how we label our variable objects. This is how we label our cells in an Excel spreadsheet. So the word cell is spelled C-E-L-L, like the cells of a tissue or organ in a body. If we were in biology, we'd be talking about the cells of organisms, and it's spelled that way. But Excel is spelled with only one L. So they kind of played, that's a marketing thing, but kind of played on the word Excel. The thing I want you to understand is that spreadsheets are every bit a programming platform. And a little later in the course, you'll learn how to create a macro that automates the entry and calculations of repetitive things so that you don't have to spend a lot of time to do that. The main power of a spreadsheet is that you can perform statistical computational process, right? Very sophisticated simulations, even artificially intelligent simulations. You can use random number generators, and then you can graph the results, and that's the primary interest of a spreadsheet. The biggest problem, though, is when people have other information, and I'm just going to stress this one more time, right? People have other types of information, and they say, oh, I know spreadsheets, and spreadsheets are great, and I can use spreadsheets to contain all sorts of information. So they open up a spreadsheet, and then they do this. They go first name, and then last name, and then date of birth, and then social security number, and then phone number, and then address, let's say street, right? And then city, and then state or territory. So they start working with this. What they don't realize is that, yeah, the spreadsheet is very familiar and you're comfortable with that, but you really need to work instead because there's other types of digital information other than numerical information. When most of the data set is non-numerical information, the numbers in here for social security number and phone are numerical, but that's more text, that's more character information. you don't really perform calculations with social security numbers or phone numbers. You might perform a calculation to determine age for date of birth, but other than that, you don't use social security numbers in calculations or phone numbers in calculations. What you'll do is you'll filter or sort for certain phone numbers, area codes, sort for certain social security numbers that start with the following numbers. And that maps to certain states, right? So there's all sorts of interesting queries that you can work with the data that's non-numerical, but it doesn't belong in a spreadsheet. And the biggest problem with teaching people how to use a hammer is that for a time, a lot of things look like a nail. And so this is one caution that I'd share with you quite a bit about that, right? So you want to use the database and you want to be able to organize things. And you'll see in the next module how it's very easy to take the same kind of tables, but then normalize them. Now, we talked in our previous class about normalizing the data tables. So there was, let's see. We went into detail about the chapters, right? So there are different terms that we use when we're in a spreadsheet as opposed to a database. If we're in a spreadsheet like Excel, then columns are vertical and rows are horizontal. But when you have a certain row in a database, that's called a record. Sometimes it's called a tuple, right? Now, if that was a double P, it would be tuple, but it's tuple. It's pronounced tuple. And a tuple is a complete record or collection of attributes that belong to a single record. So if you have different but related data types that have to do with the same item or subject, that would be a record in the database, not a row in the data set, okay? So when you have related, the goal of a database when you're building it is to simplify it and keep it as small as possible. So this is called normalization, right? Now we're giving one example here, one tuple of a patient demographic. If this was a healthcare database, you could say one record that belongs in the healthcare database is first name, right? And then last name. And notice that we're using descriptive labels for our fields. So another thing that we differentiate is that in databases, the columns are called fields, right? And the rows are called records. So when you hear fields and records, that's database. When you hear columns and rows and a cell identifier or a cell label, that's a spreadsheet. When you're talking about a record, those are all the related attributes, all the related data types for a given subject or a given entry, right? First name, last name, age, right? Body mass, you could have somebody's weight, their blood pressure, their blood type, all those different things. That one specific record for that individual would be called a tuple or a database record. Any questions about our terminology? Can someone unmute their microphone and let me know we're still with each other?
Still here.
Everybody's still with us? Okay. Oh, yeah. Oh, I have to update. Let's update our roster real quick. Since let's see, M. Kamau. That's must be a new student. So when we finish the class today, what's the first name associated with Ms. or Mr. Kamau? Am I saying that correctly? Can you unmute your microphone? There's a button at the bottom of your screen to unmute your microphone. Okay. Oh, can you chat to acknowledge that you heard what I was saying? So I just sent a chat message.
Oh, hi, Professor. I'm actually a girl, not a boy, by the way.
Well,
I'm supposed.
I said Ms.
Oh, sorry.
Mr.
I'm on the St. Thomas campus. I was actually supposed to just be strictly online. So
Oh, okay. Well, that's
yeah,
fine.
I
Yeah, this
joined
is
because I wanted to ask a question, but after class.
yes, and this is a hybrid delivery modality for the class, so being exclusively online is not a problem. Okay.
Okay.
All right, and I will be over on St. Thomas soon. They were buying tickets, and in the first week of class, I thought I'd get over there before Labor Day, but they had to do some things with the order to get batches of tickets. So I should be able to sit down and meet and greet you in person if you
All
have
right then.
the time. Yeah.
All right then. Thank you.
Yes. Okay. Awesome. So yes, at the end of class, let me show you where you can find the other recording for the other class sessions, other recordings. We, in a previous session, I think our last session, we were talking about Edgar Codd. And we said that he was the first to codify, or he codified. And so, you know, it's kind of a funny twist of words, but basically Codd was the one who framed or devised or derived. That's another word for codified, right? He determined how to work with data sets in a most efficient manner. And one of the things that he talked about in particular, after he was awarded the Turing, after he was honored by receiving the Turing Award, which is the Nobel Prize of Computer Science. So that's a pretty big deal, right? These are concepts that relate with how to organize data. So one of the ways that you can organize data for a database is to just use a top-down data table creation, right? Where you have broad categories of data elements that you break down into more and more specific levels and criteria. And that's one method of structuring data sets. And we'll examine this in much greater detail in our next module. You don't need to know how that's done now. You just need to know about the method called entity relationship, right? It's a top-down method. You have big, broad categories first, and these are broken down into more specific levels and criteria until you've kind of organized all of your data in a data set into what's called a hierarchy. So that's a $64,000 word that means, okay, we have big categories and then subcategories and then subcategories and so on. That is one method, but one issue with this method is that dependencies between the tables can slip by unnoticed. So when you're organizing how to relate data sets for a database, and when we say relate them, we mean join them. like this diagram shows here. We were talking about a data table for killer whales, orca, and it has all of the demographics. It has all of the identifying information and the characteristics of a single, each orca, right? So their name, their birth date, their tag date. So this is where you find specific information about each orca. But then there's a separate table that has to do with orca sightings. So you're out in the boat with the crew, and you see different killer whales, and you can identify the different killer whales by the tag, right? So there's this electronic tag, and the tag says, oh, that's this orca ID. So the sighting for a specific orca identity is related to the orca table specifically. And in this table, it's just the details you need about the sightings. So we do not include, oh, we saw an orca, and yeah, here's the tag on it, and that tracks with this orca ID. But now we're also going to store the name, the birth date, when it was, the date it was tagged, all of that in the sighting table. We don't want anything in the sighting table except information about sightings. The location, the GPS location, when we saw the killer whale. And then there's a separate record that identifies, okay, that event, right? You could call it an event ID. It's a pretty big event if you're in a small boat and you get up close to a killer whale, right? So that's a sighting, that's sighting number 121. That would be the sighting identity. So the only thing you have to worry about is this unique record number. That's the other aspect about normalizing data. The goal here is to have each separate data set as clean and as simple and as minimized or minimal as possible. And then you put those data sets together and relate them. And that's where the power comes in, especially with one-to-many relationships. So you have a patient record with your doctor. And if you don't have a doctor, let's pretend that you do have a healthcare professional that you see all the time. And this doctor has records in their office. And basically, when you go to visit, there's a file about who you are. But then there's also a separate file about what happened when you visited, right? So there's a data set in their software that identifies who you are and all of the specifics about you and your person. But then there's another table, a data set about your health conditions, and another table about your visits to the facility, and another table for your payment for services, right? So it's a billing table. Does everybody understand what I'm saying here? There might be one record for you, but there's many records for your visits, because you might visit more than once. It would be good if you visited more than once, if that makes sense. All right, what I'd like to do is get down here to this final data normalization. So it's a bottom-up process. It's where you take a look at data elements and you figure out what's the smallest way, the simplest way and the smallest way to group data elements together so that you have unique records. And once you practice doing that, it takes practice, but once you practice doing that with information and you start to get the hang of it, this is where very lucrative careers are born, right? People find out that they just have a very natural way of thinking about how to organize tables of data, right? Data sets. Remember that one of the things that we want is a unique record. So primary keys are the anchor in a given table. Every table, if you're normalizing data and you're breaking them down into the smallest possible data sets, there's always a special field. There's also a special field called the primary key, and that's the record number. It's usually a record number. So in each table, there are multiple records, and record numbers are very basic whole numbers, like, record number 653. That could be your patient record, right? When you're connecting them to another table, that's a foreign key. So in the image that we just saw with ORCAs and sightings, the connection on the sighting side would be called the foreign key, and the connection or relationship on the ORCA side would be called the primary key. Any questions about that? The side that's unique, that has one record, would be the primary key. The table or data set that has multiple records would be called the relationship that's formed would be called the foreign key. So in this diagram, if we have a table where we put the information to identify each different killer whale, each orca, what we're going to do, we'll have one record for each orca, and only one record for each orca. So this is the primary key of the join or relationship. But if you see that orca over and over again, oh, you saw him last week, now you see him next month, and you see him 3 times in a row, right before Halloween. So those sightings, those multiple sightings, also have that data element called orca ID, and it's related to this orca ID, but on this side, because there's many records, we call that the foreign key. Okay? Any questions about what we've just related? So this is the last part of our study guide. We'll take a short break, and then we'll jump into the the addendum, and then we'll handle one-on-one things. So important data types to remember. We talked about different types of data, like character or string data. That has to do with letters. So if you see char, char is usually a reference to the full word character, and it has to do with string data, meaning letters and symbols, not numbers, right? Real is a data type that involves numbers with decimal points. So real numbers are numbers with decimal points. You may have had that in a math class somewhere along the lines. That's often referred to as floating point or double floating point. So sometimes you'll also see the reference to floating point. Floating point calculations are calculations with decimal points, numbers that use decimal points. Integers are whole numbers. Boolean is yes, no, true, false, on, off, 1 or 0. So if a data type is Boolean, it's a field in that database. It's a field in the database that says, is this person old enough to drive? Yes or no? Is this person male or female? Male or female? Well, as it turns out, as our society evolves, instead of being purely male or purely female, as you know, that there are differences now, and not just a yes or a no, or a true or a false. So that's probably not the best example. And we'll be talking about data types later in statistics that are more granular like that, that have more variety than just a yes or a no, or an on or an off. If you have a value in a data type and there's only 2 of them and they're complete opposites, the Boolean data type is the ideal type of data to work with, because it allows you to pick yes or no, true or false, on or off, 1 or 0, right? Could say black or white, anything where there's a clear opposite, and there's nothing in between. That's one of the distinctions about Boolean that's really important. So if you have a data type that involves more than 2 extreme opposites, you would be better off creating a data type out of the character data type. This will make more sense when we get into our database portion in our next module. Whenever you see something in red in our study guide, that's something that you can be sure of is going to be on your assessment in the midterm exam, in the final exam, right? I'm going to see you on the street in 10 years and ask you, oh, hey, you remember that class we had together? There was that one thing you needed to remember about, you know, data types, and it was in red. And it was really important because it creates train wrecks. When you see something in red, there are mistakes that have been made that have caused all sorts of serious problems, right? So when you're working with scientific computing applications and you have numbers that are not used for calculations, these must use the string, char, or text data type. If they don't use the string, char, or text data type when you're setting up your data stuff, it'll go sideways. A lot of things won't work. Any questions about this particular concept in red? Okay, so you can represent data sets or data tables in a database with something called a comma separated variable, right? So what would a data table or a data set look like that's comma separated? Well, a good example of this would be the information we just talked about with tuples, right? So let's say that we have a text file, right? And we want to store our data elements in a simple text file. Is everybody with me?
Yes.
So the first thing that I'm going to enter are the field names separated by commas. F name, using this example, I'll take this and I'll build a comma separated value text file, a CSV text file, comma separated value text file, CSV. When I'm finished, I have a data file that I can import into spreadsheets or import into databases. So I'm going to type out first name and then a comma and then last name. Notice there are no spaces there. Everybody see that? No space. What comes next? Are you following along? What comes next with our example? I did this, I did that. What comes next? Age, right? And then body mass. Let's extend the example. I want you to notice that I'm not using spaces there for my field names. That's important. Body mass, let's say blood type, right? Sex, date of birth, phone, all right? So what do we put in the next line? Well, I have Tom, And I'm just going to follow the example, right? Tom, comma, Smith, comma, 53, comma, body mass in kilograms, that's a real number, so that's going to be, let's say it's 76.2 or 3 kilograms. And then blood type, we'll say O negative. And then for sex, we'll put male, date of birth 12/25/1999. So that's month, day, and year. Born on Christmas Day. Phone number 340-123-4567. Okay. Now, believe it or not, a database knows how to parse all that out because it's just the commas that are separating. Even though it looks messy and they're not aligned, it knows, oh, this first row, that must be the names of the fields. So those are the labels of the fields, and then the values that follow are what we put in each of those records under those fields. Okay. So I could keep going with the example. I could say Susan Susan Mason, and age is 26, and let's say she is 58 kilograms, and well, 58.1, because it's, just say 0.1. Everybody get what I'm doing here? A positive, female, 0701, no, 04. She's born on the 4th of July, 2007. Okay. Her phone number is 340-765-4321, right? That's a comma separated value. Okay. Any questions?
No.
Always use a descriptive name, label, or identifier. Right? Just makes things easier. The coding convention mentioned on page 89 and the use of descriptive naming for variables and objects allow for much greater efficiency when identifying coding errors. So the coding convention mentioned on page 89. Well, which page is that? If I look, I mean, basically I can go to the MIT website or Kindle, and I can look on page 89 when you're debugging. So they recommend a naming convention on page 89. Would anyone like to see that reference? Or do you each have a copy of the textbook by now so you can look it up yourself? I don't mind going there if you'd like to see it.
You could show it to us.
Okay, all right. So I'm going to go to MIT Press. Let's see. Should go to Google first. There are actually two MIT Press websites. So if it's MIT Press Publish, the P is missing. That's the one you want to get into the textbook. So you log in And if you read A Gentle Introduction to Effective Computing, I can basically go to page 89. So one of the things that they recommend when you're creating code is including comments so that people know what the heck they're looking at. They know what it's about, what it's for, and that's an important. So when you have descriptive code, when you have self-documenting code, if you have meaningful variable identifiers, you don't have A for auction ID, you don't have V for volume. You use those, you use more descriptive labels, then you're going to do much better when you're trying to debug. But then you can also leave comments, and in most cases it's a hashtag, or it's a forward slash with an asterisk, and then the reverse, an asterisk with a forward slash. Everything in between is ignored, so you can just have, you know, descriptive information there. So those are things that are really important to do when it comes to your code. Any questions about that reference? Comments and descriptive variable names. That will go a long way. There are only a few items in the addendum. Can we jump to the addendum real quick? So here's in your reading in the textbook, basically, when you read the textbook, it'll have you use the virtual machine, and in the virtual machine, it'll tell you to enter certain commands. If you have problems entering commands, if you cannot run a command, it may have to do with the 3 P's of operating a computing application, right? So have you ever tried to run a command and you get an error message, right? Most everybody's had that happen. But this is like a universal rule of thumb. There are 3 P's when you're working with scientific computing. You might not be in the correct directory. So sometimes you have to issue a command within a directory or within a folder in order for it to execute. And if you're outside the directory or outside the folder, it may not work. Here's a quick example. If I open up my command prompt, can everybody see my command prompt?
Yes.
So if I go to, let's make the font a little bigger, medium font. Let's make it 24, 24. Screen text, will make it yellow. How's that? So if I try to run calculator and I want to see if calculator's there, if I do this, I'll say, show me a directory of anything that starts with the word calculator. And lo and behold, it's going to give me a listing or in the directory for calculator. So if I enter the command calc .exe, it's going to open up calculator, no problem. But that's because I'm in the path I'm in the folder or directory called Windows, and inside Windows is another folder or directory called System32, and that's where calc is located. A lot of times when you're trying to run a scientific computing application, if you're not in the same folder or directory where it lives, if you're not there, it won't run. Now, you can tell that I'm there because it shows where I am in the path of my prompt, right? So the way this command prompt is configured, it's going to show where I am at the time. If I want to go to the root of my C drive, I can change directories and go to the C drive. And then I can look to see, okay, I have all of these different directories. The same is true in Linux. It's the same in the terminal in a Mac environment or in a graphical file manager like this, where you go to the C drive, and then inside here you have these directories, right? It's just a different presentation of the same thing. So a lot of times when there are scientific computing applications, you have to be in the same folder or path. You can also execute the command to run it by including the path. So if you don't know where your position is, or you don't include the path, it'll misfire. Any questions about what we mean by that? Okay, permissions. Did you know that on a Mac or on a Linux machine, most people don't have permission to run a command? You have to be given permission. There's a command that's used to give someone permission to execute. Now in Windows is, well, they're the flavor, they want to be the flavor of the month. Microsoft wants everybody to use Windows. So if there are any applications that are present, anybody who's on the system can run it or read the file or folder. So if you're on the system, you can read the stuff and you can execute the stuff, which is not always the best for security when you think about it. And then there's privilege, right? So you may not have root or administrator privilege, and some scientific computing applications require you to be a root or an administrator, someone with privileged credentials. It means your login account is a member of a specific security group. So specific permission, specific privilege, or your position on the system, where you are on the system. Those are the 3 Ps. Any questions? Okay. I'll go ahead and stop sharing and stop recording. And then if any of you have questions or concerns about the assignments or the solution, we've got some time remaining in the session. We can work together and share examples, or we can go one-on-one. It all depends on what you'd prefer to do. This concludes our content review for Module 1. You'll see the Module 1 assessment in here under inside the header. You'll see Module 1 assessment at the top. You'll have to have your first attempt completed by 3 p.m. Thursday. That'll be out tonight or first thing tomorrow morning before you start your day. You'll get a notice about that, and it'll say, oh, you've got about 48 hours. You have today and most of the day after. You got to have it in by 3 p.m. Thanks for joining us. That's it for now.